Device-to-device communication model, sometimes referenced as machine-to-machine communication model, is to be implemented between the homogeneous class of the IoT devices. Nowadays, there is a need to enable heterogeneous systems to collaborate and talk one to another. In a device-to-device model, communication is usually held simple, sometimes with niche proprietary protocols, in example N+, sometimes do employs heavy-weighting protocols like XML. So there is a need to provide common communication ontologies and semantics. Devices participating in such a network usually act as a multi-mode, constituting self-organizing networks, capable of exchanging the data through routing and forwarding, as it appears in example in 6-LoWPAN networks, where nodes may not only act as a producer or consumer of the data, but are also expected to act as a message router. Device-to-device model is highly utilized in the industrial automation control systems and recently very popular in developing Industry 4.0 solutions where manufacturing line devices, in example robots and other cyber-physical systems, communicate to set up operation sequence for optimal manufacturing process, thus providing elastic working zones along with manufacturing flexibility and self-adaptation of the process. It happens because of the presence of various IoT devices, frequently referenced as an industrial IoT, and advanced data processing, including big and small data. Such a device-to-device network very frequently mimics popular peer-to-peer networks, where one device can virtually connect any other to ask for information or deliver one. Comparing to the classical tree-like topology, a device-to-device communication constitutes a graph of relations rather than a hierarchist tree-like in pre-Industry 4.0 era. Along with physical devices participating in the manufacturing process, there usually goes their virtual representation, so-called virtual twin, to enable cognitive manufacturing based on the data science. The device-to-device communication assumes participating devices are smart enough to talk one to another without the need of the translation nor advanced data processing, even if their nature is different. In example, your intelligent door can inform your smart IoT kettle to start boiling water once they sense you are back home from work. Devices constituting mesh or scatter network communicate virtually over another similar way people do.